Chapter 3.1, dealing with functions. This is the extra practice. Let's look at these questions. In exercises 1 and 2, determine whether a relation is a function. So there's a number of ways that we can go about determining this. The easiest, especially when they give you a chart, and a little H chart, I would look at each of the x values and I would see, are there any that repeat? Yes. -2. So if we want to know if it's a function, when we input -2, we should only get one output, the same output. So when you plug in 2, when you input -2, excuse me, you get +4, and then when you input -2 again, this time you get 5. So that doesn't make sense, and that would be the first indicator, or the easiest indicator on whether it is a function. It is not a function because when you input -2, you get 2 outputs. You need one unique output for every input. So that's number. Now we are provided coordinates, and we look at each of the x values, and we notice that none of them repeat, so every input has exactly one output. So this could be, or is considered, a function. Yes, it's a function. Yeah, good. When they give you a graph, we look and see there's only one x, there's one x. There are 2 y values for this x value. So if we looked at that as a coordinate, we could see that 2, 2 is going to be a coordinate and 2, 3 is going to be a coordinate. So when we plug in 2, we're going to get 2 different outputs, which doesn't make sense. We call this the vertical line test. You could also take a vertical line. Let's make it a color. Let's make it a little bit bigger. And let's create a vertical line. So if we take this vertical line and we see there's only one point, there's only one point. Hold on, there are 2 points that go through that. And that's an indicator that you have 2 outputs with the same x input, and there would be one here. So that's called the vertical line test. So this is not a function. Vertical line can be drawn through 2 points. Determine whether the graph represents a function. So we don't see it. We can again use that vertical line if we want. Let's borrow you. Let's copy. Let's paste over on this one. And if we draw across, we only have 1 point going through any part of this. So this is a function. Yes, that's a function. No vertical line can be drawn through more than 1 point on the graph. Same thing here. 5 and 6, find the domain and range of the function represented by the graph. So when we say domain, we're talking about our x values. So they want a list. Since these are discrete, meaning they're not continuous. So my x values are going to be 0, 1, 2, 3, 4, and 5. Those would be my domain. That would be my domain, those specific numbers. My range is talking about my y values. So what y values do I have? I see, that was an ant. Sorry, I wasn't drawing on there. When I plug in 0, you notice that we get 4. When I plug in 1, we get 4, so I don't have to write it again. When I plug in 2, I get 4 again. When I plug in 3, I get 3. So I'm going to put them in numerical order. So my range is going to be 3 and 4, specific. Now, when we have this, yes, it is not infinitely continuous, but it is continuous through there. So what are my x values? So my domain, again, that represents my x values, is going to be from, my x values are going to be greater than or equal to, that's -3, and less than or equal to +3. So I can write it as an inequality, because how am I supposed to get all these little x values inside here? I'd never be able to write them, so I'm going to write it as a compound inequality. The range, again, I'm going to go from my y value, range is y, and it's going to be greater than or equal to 0 and less than or equal to 3, because my range is from 0 on the y-axis all the way to 3 on the y-axis. Let's see. 7. A computer printer can print 12 pages of text each minute. So, does the situation represent a function? If so, identify the independent and dependent variables. So, a computer printer can print 12 pages of text each minute. So, 1 minute, 12 pages. 2 minutes, 24 pages, 3 minutes, 36 pages, etc. So yes, it represents a function, and 0 minutes, 0 pages. So we could say, yes, it's a function. And then the total number of pages of text printed is the dependent variable, because it is dependent on the number of minutes. So it asks first, identify the independent. Independent would be the number of minutes. And the dependent, because it depends on the number of minutes, the dependent variable is the number of pages printed, the number of printed pages. And look, we don't have to, if so, identify the independent variable. If we wanted to write that, P is going to equal 12M. You understand that? So P is the number of pages. M equals the number of minutes. And so M would be the independent, and P would be the dependent variable. You have no more than 50 pieces of paper. Find the domain in range. Okay, you have no more than 50 pieces. Well, 12 pages each minute. So, I mean, we could draw that equation. So if it's 12 pages, let's do this, pages to minute. So if we have 12 pages for 1 minute, then what would 50 pages be for how many minutes? And we can do in that fashion, and we can do cross product. 12 times m is going to equal 1 times 50. 12m equals 50. And divide by 12, divide by 12, m equals 25/6, which equals 4 1/6 minutes, right? 4 1/6, yeah, 24. You have no more than 50 pages. Find the domain and range. Okay, so I'm gonna do this. I'm gonna do minutes on this axis, and I'm gonna do pages on this axis. And at 0 minutes, I have 0 pages. At 1 minute, I have 12 pages. At 2 minutes, I have 24 pages. 3 minutes, I have 36 pages. 4 minutes, I have 48 pages. And 5 minutes, I'm going to have, let's do this, pages. Let's do this, minutes. At 5 minutes, I'm going to have 60 pages. So we're going to have that, 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 and then we have 50 pages. So we would do sort of right here. So it's going to be between those. It's going to be between those two things. So if I want to know find the domain and range. So domain, what are my x values? Or my domain is going to be m in minutes. So my minutes are going to go from greater than or equal to 0 to 4 1/6 would be my domain. And then my range, which is my y values, my range or my dependent. So my range is going to go from 0, and this is pages, and my max pages are 50. Yeah. So that would be, I would probably write in that fashion. And once I drew that chart, it made it a little bit easier. So it was easier to see that. Determine whether the statement uses the word function in a way that is mathematically correct. Explain your reasoning. A function pairs each animal shelter employee with 6 animals. No, I would say no. No, not a function. Because you have employee, and that is animal 1, animal 2, animal 3, animal 4, animal 5, and animal 6. So there is no unique employee for each animal. So you have this, and since you have no idea, so I would say no. Yeah, so you would only need 1 employee for 1 animal, would be 1 unique input. All right, good, interesting, fun. Hopefully that made sense, and you're getting a good grasp on functions. All right, talk to you later.